Hello friends, this is Santosh. I'll be presenting on scaling medical imaging infrastructure for life critical healthcare applications. We describe how advanced flexible endoscopy uses this architecture. The agenda is platform architecture fundamentals. What is the core infrastructure? Real-time video processing pipelines. What are the storage architecture design principles? Then performance engineering and availability. What are the scaling strategies, optimization techniques, and how do you recover from disaster during a procedure? What are the data management and integration tools we use? How are they connected to the cloud? What is the security and compliance we are following? Then we end with case studies and future directions. See, when the medical platform fail, patients are directly impacted. The momentary system lag in bronchoscopy could mean missing a critical airway leak that could be even cancerous. A storage failure might result in lost diagnostic imagery that cannot be recreated. What are the technical challenges? So, the stream bandwidth, the single procedure produces massive amount of uncompressed data sets. The latency, the end-to-end photon latency should be less than 200 milliseconds. In best case scenarios, we have systems with 90 to 120 millisecond latency. The uptime is 99.99%. We have multiple imaging modalities, RGB, near IR, fluorescence. Each have distinct data streams with unique processing requirements. Most of the modern endoscopes are at least HD, requiring robust infrastructure, core infrastructure architecture, compute requirements. We need clusters with hundreds of CPU cores and multiple high-end GPUs for real-time processing. Dedicated resources for video encoding, transcoding, and enhancement operations. Separate compute pools for real-time versus batch processing workloads. What is the network architecture? 10 gigabits per second backbone capacity, quality of service mechanism prioritizing endoscopic traffic, multiple edge ingestion points with automatic failover capability, specialized low latency paths for real-time clinical workflows. The real-time video processing pipeline, data integration, image enhancement, apply advanced image processing algorithms for noise reduction, enhancement, color correction, etc., encoding, compression, H.265 to reduce bandwidth while maintaining quality, distribution, multi-protocol streaming to viewing stations and adaptive bitrate capabilities, tiered storage architecture, hot tier NVMe arrays, active recent examinations with sub-millisecond access latency. Warm tier is SSD storage, recent procedures up to 30 days. Cold tier is historical procedures with adaptive or intelligent compression algorithms for cost effective long term retention. Horizontal scaling and performance optimization. Stateless microservice design enabling linear capacity expansion, Kubernetes based or orchestration with automatic pod scaling based demand, intelligent load balancing considering data locality and network topology, session affinity ensuring consistent processing for procedure streams. Performance optimization, GPU acceleration for compute intensive video processing, zero copy buffer management, minimizing memory transfers, head caching for frequently accessed content, time series databases optimized for procedure metrics, high availability and disaster recovery. What is a redundancy architecture? Eliminate single points of failure through redundant power network, automated failover, continuous health monitoring with sub millisecond detection of component failures, geographic resilience, comprehensive chaos engineering and regular failover testing are essential. Partial failure, test partial failure modes, network partitions, and cascading failure scenarios under controlled conditions to validate performance resilience. Data management and analytics infrastructure, real time ingestion, processing framework, analytics platform. We propose using Kafka buffering based high bandwidth video feeds, stream processing for initial validation and enrichment. For the processing framework, it is Lambda architecture combining stream and batch processing, GPU acceleration for computationally intensive tasks, analytics platform, self-service analytics for quality improvement, feature stores for consistent model training, security and compliance framework, HIPAA compliance, AES6 encryption for data at rest, hardware security modules, role-based attribute control systems, tamper-proof audit logging with cryptographic signatures, data privacy protection, end-to-end encryption from capture through archive, hierarchical key management with perfect forward secrecy, data classification driving automated protection policies, access control systems, context aware authorization, multi factor authentication with single sign on integration, behavior analytics detecting suspicious access patterns, healthcare system integration, single sign on a federated architecture with reference pointers, PAX connectivity, DICOM interfaces converting video to multi-frame objects, intelligent routing, balancing immediate availability with source storage, DICOM web Vado interface for RESTful access, XTS frameworks enabling cross-enterprise sharing, cloud and hybrid deployment strategies, cloud native architecture, Kubernetes architecture enabling sophisticated deployment patterns, hybrid implementation, edge computing within the hospital networks for latency sensitive operations, multi cloud resilience, abstraction layers enabling portable deployment across providers. Case study academic medical center implementation. We had a deployment profile of 1200 bed academic medical center performing 50,000 endoscopic procedures. Requirements 99.99% uptime, sub-second latency. A Kubernetes orchestration enabling dynamic scaling during peak procedure times. The key results were reduced latency to under 200 milliseconds while providing virtually unlimited storage, EMR integration with federated architecture preserving video quality, successful handling of 200 plus concurrent procedures during peak time, about 40% reduction in operational costs through performance optimization. Future directions, AI and ML integration, edge computing, advanced imaging for high definition, ultra high definition 8K, 3D reconstruction from endoscopic video enabled enhanced visualization navigation assistance. Thank you.